Yes, good morning to all students. Now, in this second video of optimum design concept, we are going to see what is the optimum design for redundant specification. So, optimum design for redundant specification. In this optimum design of mechanical element, if it is not possible to develop primary design equation to the point where all the effects of subsidiary design equation, limit equation, and specified parameters are included, then it is a case of redundant specification. There are either excess number of limit equation or excess number of subsidiaries equation which cannot be combined properly with primary design equation at one time. Therefore, the optimum design of a mechanical element for the case of a redundant specification can be extremely difficult as a time. So, what is the conclusion in short? In optimum design, when it is not possible to develop PDE where the effects of all SD, LE and specified parameter are included, then it's the case becomes of redundant specification. So when we are comparing what about the development of the equation, there are either excess number of limiting equation or either there are excess number of subsidiary equation which cannot be combined properly with primary design equation at one time. Okay, therefore this is what you can say. This case is consist of, or you can consider it as a difficult case. So we'll see the steps involved in the optimum design for redundant specification. Again, the similar methodology will be adopted. First step is select geometrical parameter. Decide the basis of optimum design. Then the next step will be write down the primary design equation, write down all the secondary design equation and limit equation. Based on this SDE and LE, we are going to classify all the parameter from PDE, SDE and limiting equation. Then what is the important difference between this case and previous case? We are going to temporarily ignore some SDE or limiting equation. Then after temporarily ignoring some SDE and LE, we are going to combine SDE. We are going to combine SDE with PDE. Then what will be the next step? Identify eliminated and related parameter. So the next step will be using primary design equation. Determine the variation of optimum design quantity with each parameter group. Therefore, by using the limiting equation, substitute the optimum value of each independent parameter group in the primary design equation. Therefore, by accepting related parameters, then the next step will be using the limiting equation on the related parameter. Determine the feasibility range of the optimum design quantity for each material. Then the next step will be from PDE, replace related parameters by eliminated parameters. Then after we are going to plot the optimum design quantity against eliminated parameter and improve the limit on eliminated parameters. Impose feasible design range based on the related parameter on plot, and then we are going to determine the optimum design location, and at the last step determine all the unknown parameter using SDE. So this is what you can say the generalized method for optimum design for redundant specification. So the next step, it will be consist of optimum design for incompatible specification. For the case of incompatible specification, the limit equation and SDE, it is designed in such a way that if it is impossible to satisfy them all within the feasible design range, then in other words, feasible design simply does not exist. Therefore, it is either necessary to modify some limit or search some new material. So this is what you can say the case of incompatible design. So whenever we are going to plot the graph of log CM against the log of A max, you can see here this range it will be considered as a feasible design range. And let us consider three material 1, material 2, material 3. So these are the limit imposed by the stresses which are imposed here. So when we are going to plot of log of CM against log of A, then it becomes the case of optimum design for redundant specification. So from this figure shows the plot of optimum design quantity against the geometrical parameter for the case of incompatible specification. It is important to note that in real sense, the case of incompatible specification is a special case of the redundant specification. So you can see here, the range is feasible design range here when we are going to plot the graph of log of cost of material to the log of maximum area. So you can see here material 1, material 2 and material 3. So these are three different limiting equations are going to be imposed. Then the next case we are going to discuss is about design for manufacturing and assembly. Now design for manufacturing. The DFM refers to the design activity that is based on minimizing the cost of production and or time to market for a product while maintaining an appropriate level of a quality. A primary strategy in the DFM involve number of parts in a product. This is what you can say the general basic guideline about design for manufacture. It refers to design, and in this particular activity we are going to minimize the cost of the production or time, whatever the time which is required to market for a product. So in this case we are trying to maintain the optimum level of quality. Okay, now what is design for assembly? Now design for assembly is different than design for manufacturing. It involves making directions and methods for attaching and joining the parts of a product which will look as a simple. So when we are going to compare this DFM and DFA, it becomes DFMA. It refers to the working with both of these concepts together. So this is what I can say is the general basic guideline about design for manufacturing and assembly. So the next slide we are going to discuss about the benefits of DFM and DFA. So when we are going to adopt technologies like DFM and DFA, it reduces the part count, thereby reducing the cost. If a design is easier to produce and assemble, it can be done in a less time, so it will be less expensive. Design for manufacturing and assembly should be used for the reason if no other. Now there are some general compatibilities like increased reliability. If the production process is simplified, there is less opportunity for errors, and at the same time generally it increases the quality of the product. Therefore for the same reason it can increase the reliability. So these are the benefits of DFM and DFA. Now what will be the objectives? What participants or students will understand by considering this concept? So the differences and similarities between design for manufacturing and design for assembly, the participants will be easily understood. Then describe how product design has a primary influence. Now the basic criteria for part minimization, how the minimum number of parts are involved for the assembly. Then quantitative analysis of design efficiency, this part is also going to be understood by the student. Then critique product design for ease of assembly, and the last step is the importance of involving production engineers in DFMA assembly. So these are what we can say the generalized objective. Okay, generalized objective that we are going to learn. So from this pictorial view you can see design for assembly. Design for assembly is a method of design of the product for ease of assembly. So you can see here in broader view what we are going to call this optimization of the part or system assembly. So you can see here a design of engine assembly, and for engine assembly the concept of design for assembly is mentioned. So DFA is a tool which is used to assist the design teams in design of products that will transition the production at a minimum cost, focusing on the number of parts, handling and ease of assembly. So whenever we want to prepare the assembly in very simple way, all the parts should be assembled in simple and proper way, then it's a case of design for optimization of the part and assembly. Now the next is design for manufacturing. DFM is the method of design for ease of manufacturing of the collection of parts that will form the product after assembly. So you can see here a typical example of engine crankcase and various component assembly. It is shown. So what we are going to do, we are going to optimize the manufacturing process. So design for manufacture, it is used to select the most cost effective material and process to be used in the production in the early stages of the product design. So what is general DFM? DFM is the method of design for ease of manufacturing of the collection of parts that it will form from the product after assembly. So what is differences between these two? Differences between design for assembly and design for manufacturing. When DFA is going to be concerned, it concerns only with reducing production assembly cost. It concerns with reducing product assembly cost. Then it also minimizes the number of assembly operation. Then the next difference is individual parts tend to be more complex in design. So these are the design for assembly important highlights or key points when we are going to compare with it DFM. Now what is DFM? It concerns with reducing overall part production cost. So here you can see it is reducing product assembly cost, and DFM is reducing overall part production cost. Then it minimizes the complexity of the manufacturing operation. And another important difference part is it uses the common datum features and primary axis. So this is what you can say, design for manufacturing and design for important assembly part. So in general, in this particular video, what we have discussed about what is the optimum design for redundant specification case, it was there, and what is design for assembly and what is design for manufacturing. So in case of optimum design for redundant specification, what we have learned, when it is impossible to combine all the SDE and LE, and we are not able to combine it with the PDE, then it becomes the case of design for redundant specification. Okay, then what in the next slide, what we have discussed? We have discussed about design for assembly and design for manufacturing. So whenever design for assembly is going to be considered, it is concerned with the reducing products assembly cost, and if you are talking about design for manufacturing, it concerns with reducing overall part production cost. Okay, so this is all about this video. So in next video, we are going to discuss how various principles of optimum design can be implemented for the betterment of the society, and we are going to consider certain typical applications. Okay, thank you. So please comment any queries, suggestion for improvement of this video. Thank you.